Here is our second vector component example. Hamlet decides to do some sulking. He morosely walks 15 feet east and then 18 feet in a direction 20 degrees south of west. What is his resultant displacement? I've already drawn a little compass here. Let's draw out what Hamlet does. So let's say Hamlet starts here and walks 15 feet east. And then it says 18 feet in a direction 20 degrees south of west. Okay, so here would be our western line. And it says he goes south of the western line. So 20 degrees south of west would look something like that. So let's draw that line a little bigger. And our 15-foot one, that looks about right. So this says 18 feet here. And let's label this angle as 20 degrees. Okay, so remember when you're finding the resultant displacement, you're finding the difference between where the person starts and where the person ends up. So in this case, where Hamlet starts is here and where he ends up is here. So we're trying to find this blue line. And we can make a little small triangle out of that. So overall, Hamlet goes this far in the x direction, and then that far in the y direction. So already we see that he ends up going overall southwest. Now we have to figure out by exactly how much. So we want to end up finding the magnitude of this thick blue line, and we want to end up finding this angle. And what we can do is use components. We have two vectors here. We've got vector A and vector B. And if we can find out how far each of them go in the x and y directions, we can add them up and figure out our vector C. So let's get started. Okay. Now the x component of vector A. Does vector A go off in the x direction at all? Well, yes, it does. It's entirely comprised of the x direction. That would be positive 15. As you can see. How about the y component of A? Well, there is no y component of A, so we just say AY equals 0. Now let's move on to vector B. Does vector B have an x component at all? And the answer to that is yes. I'm going to switch colors here to red. Vector B goes off in the x direction that much. Now, how would we figure out the x component of B? Well, if you remember all the way back from geometry, you'll notice that this and this is the same angle. So we can label this as 20 degrees. So we have our angle here. So this is bx. This is our hypotenuse, which is 18. Again, we can use the cosine function. So we say the cosine of 20 degrees is equal to is equal to bx over 18. So then we have bx is equal to 18 times the cosine of 20. Of the cosine of 20. My bad. Now what am I forgetting here? I am forgetting a negative sign. The reason bx has to be negative is because it's going overall west, and recall that west is the negative x direction. So we're just going to write bx is equal to negative 18 cosine of 20 degrees. And let's just solve for that right now. I calculated earlier that it's going to end up being negative 16.914. All right, let's move on to by. Now what we're looking at here is how far vector b goes in the y direction. So remember, after Hamlet has walked 15 feet, he ends up here, and he ends up going this vector. Does vector b go off in the y direction at all? The answer to that is yes, it does. It goes this far in the y direction. So this line here is going to be by. Again, we can use the sine function here. We can say that the sine of 20 degrees is equal to by over 18. So by is going to end up being 18 times the sine of 20 degrees. However, there is something I'm leaving out here. by should be negative. And the reason for that is he's going south. Remember that south is the negative y direction. So we're going to write by equals negative 18 sine of 20 degrees. And earlier I calculated that to be negative 6.516. Okay, so now we can add the components of the vectors to figure out the vector overall. And remember we called that vector c. So the x component of vector c is going to be 15 plus negative 16.914, which ends up being negative 1.914. Let's think about for a sec if that makes sense. If Hamlet started here, that means he went overall this far, that blue line, in the x direction. Now our answer for CX definitely makes sense. This line is pointing in the negative x direction, or west, so this negative sign makes sense, and this is also a really small line, and this is a pretty small number. So that looks right to me. Let's do CY. So we would just have to do 0 plus negative 6.516. And that ends up being negative 6.516. Let's think about if that makes sense. So if Hamlet started here and ended up here, that means he went this far in the y direction. And the negative sign makes sense because overall he went south. And the actual number makes sense because this line is pretty big but not huge. Okay, so now what we can do is we can find the magnitude of C. So what we just found is we found this line and we found this line. And now we're going to find the hypotenuse. And to do that, we do C, magnitude of C is equal to the square root of negative 1.914 squared plus negative 6.516 squared. And you should end up with 6.79. And what are the units here? Feet. Don't forget your units. All right, now we have to find the angle. Now the angle we want to find, as you recall from earlier, is this here. you always want to find the acute angle rather than the obtuse. You wouldn't want to find this. You want to find this. Basically, you want to find what angle he could have just walked to go in a straight line. So that's actually pretty easy. You can just use the inverse tan function. We know that the y component, or the opposite, remember this is the opposite, is 6.516. And then the x component, which is 1.914. Now, if you recall from one of the previous videos, we do not need to include the negatives here. When we put in the direction words, that will take care of our negatives for us. So, 73.63 degrees is what you should get when you plug that in. All right, so what are our direction words? Well, overall, Hamlet went west and south. So, basically what he did is he went 73.63 degrees south of west. Here's our western line, and then he went south of that. So, if you guys see, you see that our direction words take care of the negatives. This negative here for the x direction indicates west. This negative here for the south, for the y direction, indicates south. So that's why we don't need a negative inside this inverse tangent function, because S and W both indicate negatives. And if we circle all of this, that is our final answer.